Okay, this video is more Thevenin theorem tips for calculating Thevenin and Thevenin. My first tip is that if you have not watched the first one or two Thevenin's videos and then tried to work a few problems, this is the wrong video to be watching. You need to have tried, you need to have succeeded or failed a few times before you come back for the tips, or they won't make any sense. So what I'm trying to show you here is a quick video on some ideas. If you take a look over here where I say that this is a complicated circuit, somewhere in that complicated circuit exists, in all your working problems, exists a situation where when the load is removed here, that you have a resistor hanging in the wind up here to the left that gets no Thevenin voltage, in which case the voltage that you're looking for is directly located at R2, so Thevenin is R2. Every single program, every single problem on the planet will either have that resistor there, or it will be this kind of scenario where that resistor is not there. If it is not there, then the Thevenin voltage is still the voltage across this resistor that sits in parallel with the gap. What gets people in trouble is this resistor up here in the red circle that's hanging in the wind. It does not exist when calculating Thevenin voltage. It is ignored. It has 0 volts and 0 current across of it. The second case does not have that resistor, but you still have to chase down, where is my component? Where is that resistor that causes that Thevenin circuit? Now, one of my biggest tips is redraw, redraw, and redraw. You have to be drawing circuits to have any chance. If you've done nothing but watch my videos, and maybe you were smart enough to take down notes, you should know that I keep redrawing stuff. It's really difficult to study this advanced stuff if you don't have stuff in front of you. Now, in addition to Thevenin, a couple of observations. Here's a complicated circuit. I've got a load sitting over here to the right, and I just want to calculate R Thevenin. So I take the load out of the circuit at some point to do that. As you can see down here, I have taken the load out. Now, when you do that, you also have to open or short the power supply, and then you compress from the opposite end of where the meter is. Well, here's where the meter sits, measuring the resistance, looking into the circuit, but you have to start compressing from the left side, moving towards the right. Does that make sense? This is kind of counterintuitive because in a normal circuit, if you were solving this complete circuit here in green up at the top, you would take this battery and get rid of it and solve the resistance from the left side, moving towards the right side. So you would start over here in red and compress backwards, whereas on the Thevenin circuit, you're starting on the left and compressing towards the right. So I just wanted to give you a small few tips that you will be doing this over and over and over as you analyze these circuits. I highly recommend you look online. Be careful. It's easy to get into too much high-tech crap. Ask me some questions. I'll help you where I can, and good luck.